Okay guys, going to be recording the vodcast for homework 2.2. Kelsey's here visiting me right now. Oh, I'm sorry, she just reminded me that's homework 2.3. Sorry about that, thanks Kelsey. You notice this homework assignment marks a big shift in what we're doing from looking at reactions to interpreting the reactions as batteries. The first thing, okay, so this is homework 2.3. The first thing you want to do when you do any battery problem is you want to analyze who is the anode and who is the cathode. You want to do this even before you even look at the choices. Do this automatically. So we know that the cathode is the one who is higher up on the chart. So I have nickel and I have zinc. And I'm going to look and see who is higher up on my chart. I see nickel and zinc. So nickel is higher up. Okay. That is going to make nickel, this thing here, this is the cathode. We know the cathode is positive. That's going to make zinc the anode. And we know the anode is negative. The next thing we want to do is we want to do electron flow. We're going to do this always, even before we look at the choices. Okay. We know that electrons flow from the anode to the cathode. Okay, that's going to make this light bulb light up. Or it would show some value if it were a voltmeter. Okay, now do that always. Now let's go and look at the choices before we have to do anything else. Okay. Notice they have a salt bridge. It contains some generic salt made of the anion. We put nickel in its own solution and we put zinc in its own solution. So it says identify the anode of the cell and write the half reaction that occurs there. Okay, so we identified the anode above. The anode was zinc. And we know that anox red cat, so oxidation must be happening there. So oxidation would mean that zinc is going to Zn 2 plus, and it's going to lose 2 electrons right there. And we might as well go up and put that in here. Now if I did that, you would have seen that I had already had answered that question. So it says write the net ionic equation for the overall reaction that occurs and calculate the value of each cell. Okay, so let's do the oxidation first. We know that Zn 0 goes to Zn 2 plus 2 electrons. That's happening at the anode, and at the cathode we have nickel. So nickel 2 plus. 2 electrons are being added to nickel 2 plus to reduce it to nickel 0. So this is what's happening at the anode. There's what's happening at the cathode. We want to calculate these, so we know that E cell equals negative E ox plus E reduced. Okay. The value for the oxidation one, which we're going to flip, according to our chart, zinc is negative 0.76. And the value for nickel is negative 0.25. So I'm going to have a negative 0.76 plus a negative 0.25. So it's going to be 0.76 minus 0.25, so 0.76 minus 0.5. So this should be 0.51 volts. This reaction is spontaneous. It's spontaneous for 2 reasons. The battery worked. That's the qualitative reason. The quantitative reason would be that each cell is positive, and if you calculated delta G, that would be negative. All right, so good problem. Bye-bye.